told, you might be told it's like a puzzle. So 15 people ride their bike. So this is 15 people. So you therefore know, and you've then got to make it like a ratio. You've then got to say, right, well, I know that 15 people is 90 degrees. And now I say I want to work out how many people that go by car. So I need to work out what 72 degrees are. So what do I do? What's the method to do that? Any thoughts? Either speak or write in the chat, wherever you or on the screen. Why 90 divided by 50? Yeah, that's right. Yeah, so what I've got, so I know that 15 people is 90 degrees, because that's what it's telling me that. Okay, so it's told me that there. So then I've got to do one of two things. I've either got to find out what 1 degree is, or I've got to find out one person is how many. So I've either got to kind of work out this that way round, or I've got to work out one person. I've got to work out, that's the method to do it. So I've got to do one or the other. And because I need to work out what 72 degrees are, it makes sense to work out what 1 degree is. So I need to work out what 1 degree is, because what I'm trying to get to is 72 degrees. That's kind of where I need to get to. So then what I have to do is I've got to think, right, well, how do I do that? How do I go from here to here? And I could say, right, you've got to take away 89, but that doesn't work. You're not allowed to do that. It's a multiplication thing or a division thing. So to get from there to there, I divide by 90. Okay, because I'm trying to work out what 1 degree is. So to get from here to here, I've got to do the same thing. It's a bit like when anything you do in algebra, you've got to do the same thing to both sides. So I've got to divide this by 90. So if I do 15 divided by 90, what do I get? 15 divided by 90. I get 0. I'm trying to do it in blue. I get 0.166. It's recurring. So now I know what 1 degree is. And then I've got to get to 72 degrees. So how do I get from there to there? I've got to multiply by 72 to get from there to there. So to get from there to there, I'm going downwards. I've got to divide. This one here, I multiply it. So I've got to do the same thing with this. I've got to multiply by 72. So I've got that multiplied by 72, which gives me 11.99 people. So I'm going to go for 12 people. Right. So on a scale of 1 to 10, 10 being fine, tell me whether that makes sense or not. Okay. Okay. So most people get that, but so let me explain it for something else. Okay, so let's do it for another number. So if you get it, then don't write on the screen, just work it out on a piece of paper, and I'm gonna try and go through it again for those people who are not clear on it. Okay, so we'll just do it for different numbers. Okay, so this time we're gonna say 30 people. Okay, so do it on a piece of paper and try and work out, we're gonna try and work out the car bit. So if you completely get it, that's great. But just try and do it for those examples and just mute me for a minute because I'm just gonna try and explain it for those people who don't. Okay, so write it out as a write it out. So so if you don't get it, write this down on a piece of paper. So what we've got 30 people, because that's ride the bike, and ride the bike is 90 degrees. So we're trying to find that, but we're told that 30 people ride the bike. So we know that 30 people is 90 degrees. Okay, so just write that on a piece of paper just so you get it clear. And we're trying to find 72 degrees. That's what we're trying to find. We're trying to work out how many people is 72 degrees, because that's the car. That's what we're trying to figure out. So the first thing we do is work out what 1 degree is. How do we do that? We're going to divide this by 90, because 90 divided by 90 is 1. So then we've got to divide that by 90. So grab a calculator and work that out. So you should get 0.3 reoccurring. And now we've got to, so we now know 1 degree is 0.3, but we've got to try and find out what 72 degrees is. So we've got times that by 72. And then we've got times this by 72. You just, whatever you do to one side, you do to the other side. It's like a sort of parallel thing. So we're now timesing this thing here by 72. So we get 24 people. So therefore the car is for 24 people. Right, so on a scale of 1 to 10, is that any higher? Have we increased from a 2, or have people increased to a, are you now at a 3, Leo, or just a mystery? Okay, maybe you've just never seen it before. But it's like you're trying to make something equals, you're trying to make 1 degree equal something. Have a look. So I'm recording it now. So watch it again. Watch this bit of it again and see if it can make sense. Okay, but I'm just going to move on because I think most people get it. Okay, so right, something like that. So in which country was cricket the most popular sport? So which country was the most popular sport? Then India. Right, so another popular question on this, which you might get. So in which country do most people play rugby? So what would be the answer to that? In which country do most people play rugby? Okay, why might that not be the question? Why might that not be the answer? Go on, Michael. Would it be though? All right. So would it be though? So why might that not be the answer? Yes. Yes. Anyone know what the population is in India? So England's about 60 million or something. Can someone Google it for me? Someone Google what population in India is. Nick, you've got a Lord of the Rings hat. Have you been there? Did you go to have you been to place in New Zealand? We went there. My family, we went there some years ago. That's where so my kids have all got those hats. That's where they got them from. What was so strange about it? Because we went to Hobbiton and they had the whole, with the set and everything. And it was like a sort of tour. You kind of went around it and things. But the thing was so weird was they asked the people at the beginning of the tour how many people had read the book, Lord of the Rings. And you're thinking like, duh, like why would you be here if you hadn't read the book? And the majority of people on the tour hadn't read the book. Just like, what? Why would you go on the Hobbiton tour if you hadn't read the book? It was very strange. It was very sad. I mean, it's such a great book. Yeah, it was a cool thing to do. It was ludicrously expensive. The most interesting thing was going in the what's it called? The pub thing. What's it called? The green something. What's it called? Yeah, place where the prancing pony. Yeah, I thought it was a green something. But yeah. We went in the pub. But is that the one in Hobbiton? I can't remember. Yeah. Anyway, so you went in the pub and you got a drink. That was the coolest part of it. Um, yes. Anyway, so because and this is always like a trick question, isn't it? Because it's like, well, which country do most people play rugby? Well, obviously UK, but it's not. It's like when you think about it, because there's this proportion. So let's say this is, I don't know, what does it look like? 30 degrees. And so let's say that's about, I don't know, so we worked out, so that was 30 out of 360. So that's a 12th. So a 12th of the people in the UK play rugby. And let's say this is smaller, say it's a 20th. So a 12th of the people in England play rugby, That's a 12th of 60 million. This is a 20th, but of 1.4 billion. It's like, that's a lot more people. So more people play rugby in India. So take care with that question because it's people get it wrong, which is why they ask it. Frequency diagrams. So yeah, so similar to a bar chart. Yep. And this one here is a frequency polygon. Where do you plot? So on here, if you've got a frequency diagram and you want to make that into a frequency polygon, where do you mark the points? Which points do you link up? Someone want to put them on? Where do you put them? Okay, it's not there. You don't put them there. If it's cumulative frequency, you do things at the top end of the bar. But if it's frequency polygon, you don't do them at the top end of the bar. Anyone else? If it's not going to be the top of the bar, where's it going to be? Well, there's two other options, I suppose. It's always in the middle. So for the frequency polygon, you always put it in the middle, just to confuse you. So it's like that, yeah. So you always put it in the middle of the bar. Yeah, and so cumulative frequency, it's always at the top of the whatever the class interval is. Frequency polygon is always in the middle. Just to confuse you. So it's there. It's always in the middle. And that'll be a frequency polygon. And you don't do it, it doesn't kind of go to these bits here. It's just kind of like floating around in the air. Okay, scatter graphs. So you would put everyone's internet. Everyone keeps flying out of the room and then like being in the waiting room. Everyone's internet's dodgy this morning. So scatter graph, you've got two pieces of information and you put it in scatter graph like that. And then what do you put? What's the next thing with scatter graphs? What do people put on it? Yes, it's a bit like a line graph, a frequency polygon. So what do you then put on it? Yeah, so someone will put it on and multiple people can put it on, it's fine. What's it called? What's it called? The line of what? What's it called? The line you put through the middle? Yeah, thank you. The line of best fit. And if you get asked that, there's certain things that you're then asked about it. So how do you then have to sort of describe it? So what's the method in which you describe it? What they're looking for? So you make a line of best fit and then you're asked to explain something, what you asked to explain and kind of how do you then describe it? What's it kind of showing you, the line of best fit? Yep. So yeah, you're right. So the one word is correlation. So they asked you about the correlation. And what are the options? So what would you say? What type of correlation is this? Well, two options. It's either positive or negative. So is it positive or negative? Yep. It's the same way. It's the same as when you've got a graph. So a graph is y equals mx plus c. And if you've got lines on a graph that go that way, it's positive. If you've got lines on a graph that goes that way, it's negative. So it's the same thing. So it's positive correlation. And then the next thing that you're asked is it strong or weak? So is it positive or negative, strong or weak? Yeah, it's strong. Why? Why is it strong? How would it show? Yeah, the points are close together. So what would it be? So let's make this weak correlation. So what would it look like if there was weak correlation? That's it. Yeah. Yeah. There'd be kind of points all over points all over the place. Yep. And sometimes you'd be told that there's an outlier. So if you've got a point, say up there somewhere, say they're all close to the line, and then you might have an outlier, which is some other point up there. Yeah. So it's positive or negative. The word's correlation, so that you get asked about the correlation. Ask it positive or negative, or strong or weak. That's kind of what you're going to be asked for with that. Right. So what's that one? So draw a line of best fit and describe it. So just write the words on the screen. So draw a line of best fit and describe the correlation. Good. Yeah. Thanks, Clara. So it's negative. Is it strong or weak? Yeah, it's negative and it's strong. Yep. Right. Okay, so that one's going to be positive, that one's negative, and if it's all over the place, okay, they haven't got an example. If it was all over the place, then there's no correlation. Okay, line of best fit. So, how you use that is that you're then asked to predict something. So, if the car was 5 years old, what would the value of it be? What would you expect the value of it to be? How do you figure that out? We'll draw a line. Yeah, that's great. Yeah, so you draw a line from the 5, but not up to that point. You don't the point of the line of best fit is you draw it to the line. That's why you have the line of best fit. So you draw it from 5, yep, and across. Yep, that's it. Okay, so Jethro, do one for, let's predict it when it was 11. So if the car was 11 years. And Joseph Hammond predict it if it was 1 year. Yeah, it's always hard on these things to draw it on the, yeah, so about 1,000. Yep. And Joseph, if it's 1 year, what do you think? Yeah. Kind of yeah, so maybe, I don't know, somewhere a bit less than 11. Yep. Right. These are, I'm not going to do this because I don't think you need this for, right, cumulative frequency. This is more a higher level thing. So so Andy, I know you've done this recently. So Andy, do you want to do that? Fill in the cumulative frequency, how you do that? So what he's doing, he's got 6, and he's adding 6 and 13, which is 19, adding 13 and 17. He's probably getting his calculator, and he's doing his head. Yeah, so you're adding those ones. And then when you plot it, Poppy, where do you plot it? Plot it. This is where you said for the last one. So if it was frequency polygon, you plot it in the middle, but then where would you plot this? This is what you said for the last one. So I would plot it here, and I would have 0, 10, 20, 30, 40, 50. And I'm going to go up here, and so the highest number is 60. So I've got 10, 20, 30, 40, 50. Yeah, so where do I plot it? I plot it at the, so it's 10, so the higher bit of this bar is 10 and it's 6. So it's going to go there somewhere. The highest part of this bar is 20 and it's 19. So 20 and I go up to 19. The highest part of this bar is 30. So I go across to 30 and it's going to go up to 36. Yeah, so it's the highest part. I look at these numbers here and that's where I'm plotting it on this axis here. Yeah, so I'm plotting it all on that one. It was a frequency polygon, I plot it in the middle. Okay, so that's what cumulative frequency is. Okay, I'm just showing you that. So cumulative, the word cumulative means the culmination. Let's write that. Right. Tell you what, let's do something else for a minute. So where are you going to be in? But tell you what, let me explain to you what we're doing the next few weeks. I'll come back to that in a sec. Uh, sorry. So we don't have many lessons left. So today is this 14th of May, and we're doing the data. Then we've got next week, and then there's a gap, as you can see, because it's half term. So we won't have a lesson in half term. And then I'm going to do two things. So there's actually I might switch the order of this around so you can do that over half term. Yeah, probably will switch the order of that around. Okay, so basically there's going to be we're going to do a test at the end of the year because I just think it's good for you to have to revise through everything that we've done and to do a test. So we're going to do two, it's going to be in two parts. So this one, I'm actually going to move this here so you can actually do it in half term. And I'm going to put see how I do this now. Very clever. So it makes sense. Okay, so over over the half term, there's an exam and it's a foundation paper. Okay, so it's yeah, it's a foundation paper to do. It'd be better, much better if you did it. Much better if you revised and then tried to do the foundation paper and do it in the actual time. So most of you, I don't know whether you know all this, but there's two papers for maths. There's foundation and higher. And the higher one, you can get grades, you can get higher grades. So basically you can get 6, 7, 8, and 9. The foundation one, you can only get 4 or 5. Four's a pass, so it's a pass mark. But the higher one, and this course is for the higher, but I'm actually doing a course for the foundation and the higher next year. So this is a foundation paper because you've still got a while to go before you do the exam. So that's one part of it. Yeah, it's all, yeah, you're right. Yeah, so it's core and extended. I'm actually switch this and make it, because it's an Excel paper, so I might actually switch the paper, but it's the same principle. So core and foundation are the same. I don't know why they don't do the same thing, just to make things, and it's higher and extended. So depending on which paper you do, either core and foundation or higher and extended, just to confuse you. So I might actually switch the paper around, but the thing's the same. The point's the same. So there'll be a paper to do over half term, and then we're going to do in the lesson. So on this lesson here, this will be the one after half term. We're going to do not all the lesson, but about half the lesson. We're going to do it'll be a multiple choice paper to do in the lesson. Maybe not multiple choice. And then I'll do a paper. So I haven't worked out what I'm going to do. Yeah, yeah, right. Yeah. How was the how was the how were people's maths exams? I think Andy and Jethro, you've done maths. You've done a maths paper. How was it? You've got another one tomorrow, I'm thinking. How did it go? Silence. Or either writing a lot or it's silence. Good. He's typing a lot, Poppy. What was suspense? So Andy just says he's passed and Jethro is writing a lot. Uh right, let me show you. So okay, so have a play with this for a minute. It's just got nothing else to do with anything. It's just to give you guys a break. So we're still waiting for your message, Jethro, so keep writing. So everyone else just have a go at this for a minute. I think it's quite cool. Mhm. Mhm. Yeah, but it would only have been 1 mark question. So that wouldn't have been a big thing. Okay, they're fun. They're fun shapes to do. Okay, so let's continue with this. Um, so these are, the donuts when you go to a fair, or I don't know, some shopping centers. They sometimes have in a truck or something. They had these like fried donuts. People fry these donuts. And it's this formula. People just find it hard to remember. So it's fried donuts, fry well. So I'm forgetting this bit. So fried donuts. So you've got fried donuts, and you can write it like that. You can write it in one of those triangle things. So you've got frequency density equals frequency over width, or you write it as like that because then it's depending on which bit you've got, you can work it out. And this is the hardest part of this, like the whole thing on data. So scribble down that formula, write down that formula somewhere because you're going to need that. Are they worth it? Do you think Krispy Kremes are worth it? Worth it? They're so expensive though. They are so nice, but they are very expensive. They're like more than £1 a donut, aren't they? Yeah. I think Americans do donuts well. I think Americans do. Yeah, I think Americans just do like snacks. I think they realize that you have to sell things. I was at a church on Sunday and we went in to have coffee afterwards, and I basically just knew that what they would have. Sorry, this isn't working. Why is this not working? I just knew that what they would have would be coffee and some biscuits, and it's just like very lame. I think you would just never get that in America. You would just never have go somewhere for like some entertainment thing, or visiting something, or like a church or anything. They would never just give you coffee and a biscuit. It's always going to be something, coffee and donuts, or coffee and cakes, or coffee and something. It's seem to realize that you've got to kind of sell things well, and particularly church things. I think it's just not really, we don't do it very well here. um okay, so we've got frequency density, and it's frequency over width. And this is like, I know that some of you have done this before. I know some of you have done it before. Some of you haven't. Um, so you have to figure out what the width is. The width of this one is 5 because it's going from 15 to 20. The width of this one is 30 because it goes from 20 to 30, and the frequency is that. So if you're gonna just plot this one normally, you would plot it. If we're just going to plot the frequency, uh, it would be like that. So you would have this one goes from 15 to 20, 15 to 20, it goes up to 15. This one goes from 20 to 50, and it goes up to 15. Yeah. And this one kind of, so the reason why you use histograms is because this one makes it look like there's loads more people in the 20 to 50 age group, but there aren't. There's the same number. But because the bar is so much bigger, it makes it look like there are so many more people, but there aren't. So that's why you use frequency densities. So on this one here, if you look at, oh, hold on, right, okay, I'm gonna look at this one here. Right, so right, so say for this one here, I've got this bar, this one here, the width is 10. Okay, so I've got a width of 10, so I was going to put width of 10 here, and the frequency is 40. So to work out the frequency density, I'm going to put frequency, which is 40, divided by the 10. Okay, so it's going to be 40 divided by 10, so frequency is 4. This one here, I've got frequency of 6, and then the width is 5, so this time it's going to be 6 divided by 5, so it's going to be that. But then this one, I've got to kind of use a bit more thinking, because I have to figure out, I've got to, and it's more helpful maybe to do frequency density here, and I've got frequency here, and I've got, so I'm making it into that triangle thing. So I can say, right, so in this triangle now, I've got the width, which is, for this one here is 20. The frequency, I don't know, that's what I'm trying to figure out. But I've got the frequency density, which is 2.6. So I've got 2.6 here. And because they're next to each other, the point of this triangle is I multiply those two things together, and that will give me the frequency, which will be 52. And this one will be the same. So what will this one be? So I'm going to put it in here. And I've got frequency density, which I know is 1. I'm going to do this one here, which is, this time I've got a class width of 10. And I'm trying to figure out this one here, so it's going to be 10. So it's using this formula with the information that you've got here and using the class width, and they've actually just put the triangle there for you. And this is just like, they just put it's just that. So let's try another one. Sorry. All right. Right, so this is the triangle thing. Okay, so let's see if people can figure these things out. It's like a puzzle. You've got to think about which bit of information do I have and which bit can I figure out. So these ones here are the easier ones to work out first. They're the kind of ones to do first. Okay, so let's see if people can work them out. Okay, so Joseph, see if you can figure that one out. Nick, do you want to try that one so you can figure that one out? And Tom, do you want to try that one so you can figure that one out? So you've got the width is 30. You've got, so the width of this one's 30 and the frequency is 30. So you've got 30 here and 30 here. So you've just got 30 divided by 30. It's not, it's going to be 30, so it's just going to be 1. That one there's going to be 1. Does that make sense, Joseph? So this one here is just going to be 1. Okay, so let's look at this one here. So Nick, so you've got the class width is 20 and the frequency is 40. So for this one, you've got the frequency is 40, the class width is 20, so you've got 40 divided by 20, so it's 2, yep. And Tom, can you do this one? So you've got the class width, which is 180 to 210. So the class width is 30, and the frequency is 18. So you've got 18 divided by 30, which is whatever that is. What is that? So you've got 18 divided by 30 equals 0.6. Makes sense, Tom, or not? So does it make sense where these come from? Because the next bit's more difficult. So if this bit doesn't make sense, the next bit's not going to make sense. So tell me, people, is that confusing or okay or makes sense? Other people? Okay, right. Okay. Let me what was the bottom one? So the bottom one was 30 divided by 18. Yeah. Okay, so tell me so those of you who are confused, does it make sense? So say for this one here, which Nick did. So this one here, you've got to put it into this thing here. And what's the frequency? So the frequency is in the frequency column, and that's 40. So that's 40 there. So you just got 40. And then the class width, so the width is this bit here. And it goes from 160 to 180, so it's 20. And does the bit using these triangles make sense? Is that the bit that's difficult? Like how to use these triangles? So the point of using the triangles is because this is on top of this, it's just divide. So then you've got 40 divided by 20, which is 2. So that's where the 2 comes from. So let me just explain the second one again, just so this one here, you've got this is now 130. Sorry, this one here is now 30. It's 210 minus 180. The width is 30. The frequency is 18, because that's what it says there. And then we're finding out the frequency density. So it's 18 divided by 30. Oh, you're right. So is that what you said earlier, Shiva? Can you see the mistake I made? Because I just put that the wrong way around. That's 18 divided by 30. I put the wrong way around there. So it's, yeah. And then the next bit, so if that's okay, then you can hopefully work out the next bit. So the next bit, what you then, on the diagram below, you haven't got, there's nothing on the side here. So you have to work out these bits here to work out how to put the things on the side. So can anyone figure out how to put what you do with this, what you do with this information here in relation to labeling this side? Yes. So this bar here, this is the 100 to, so let me color code it. So this one here is this bar here, because it's 100 to 130. And this is frequency density, which is what this is. And we've just figured out it's 1. So therefore, this bit here must be 1, because this bar here goes up to 1 on the frequency density. We've just figured that out. Let me yeah, thanks. I pressed the button, it came in. And then we figured out that this one here was 2 and this one here was 0.6. So the red one here is 2. which is this one here. And it goes up to 2, and this one here is 0.6. And then you have to then figure out, and the most difficult part of this then is to figure out, hold on, it's not, I didn't tell you in the right order, I don't think. Okay, it's this one here. And then once we've now labeled this bit up here. So you then got to figure out this bar here and this bar here. We don't know these ones. This is the 130 to the 150 bit, which is this one here. So this is the red one here. And because we've now got this labeling here, we now know that the frequency density is 4.2, something like that. So we now know this is 4.2 because we can read it off this graph. So we've got 2 unknowns here. So we know this is 4.2. We know that this bar is 20. So we know that. So what's the frequency going to be? Just trying to fill in that table. So anyone, what would this be? How would you work out the frequency? Yeah, you got to multiply it because it's like they're both in the bottom. You multiply them to get 64. Okay, so try and work out this one. Anyone try and figure out that one? Yeah, 60, thank you. So you've got, so for this one here, this is the, we've now got the 150 to 160 bar, which is this bit here. And we know it goes up to 6, so that's where the 6 comes from, because that's the frequency density, and that's frequency density. So we're sticking it in here. So we've got, this is 6. We know that width is 10, so it's 10 times 6, which is 60. Okay, let's look at another one. And this is hard. This is just like, it's just like level, I know, sort of 7 or 8. So you've got to start from somewhere, and the formula is frequency density. So fried donuts fry well. So we have to work out the frequency density. We can't do it from this one here. So we don't, because this one here, we don't know this and we don't know this, but we can work out the frequency density for the other ones. Okay, so Clara, try and do that one. So you can do that one. And Hannah, Kay, try and do that one. And Sheba, try and do that one. And Evelyn, try and do the bottom one. Yep, so that's the width. Yep. I don't know. I didn't make this slide. I just borrowed it. I just gonna got it off there. Okay, so you did 63 divided by 15. Yep, great. Well done. Yep. So Clara, Hannah, and Evelyn, do you know what you're doing, or are you no idea? Okay, so we got okay, so for this one here, we've got the class. So what's the class width, Hannah? Nope. So this is the frequency. This is the class interval, and this will tell us the class width. So what's the class width? The class width goes from 20 to 25. So how big's the class? Goes from 20 to 25. So it's actually going to be 5. So you've got the class width of 5. So I'm just going to put it into this table here. So we've now got the class width, which is 5. And what's the frequency? Yep, the frequency, and that goes at the top. So it's 24. So therefore, what would the frequency density be? What do you do with the 24 and the 5? Yours the same, Clara. So you're right. You've got the class width, which is 10. Yep. So do you want to divide? Have you got a calculator? That's it. Yep. And you've got 24. Yep. That's right, Evelyn. Good. Yep. So you've done, so you got 24 divided by 5, Hannah. So you got 4.8 there. And then it's like a puzzle because you've now got the frequency density and you've got some information here and you've got the heights of some of these bars. So you have to kind of figure out how am I going to label this? How's this going to work? So because we've got the 20 to 25 bar, that's where you start. That's the bar that's there. And we know that's 4.8. And it's already worked out to be 4.8. So we know this bar here must go up to 4.8. So then I think Poppy then's figured out, well, that's 4.8, that must be 5. This must be 4.5. Just basically kind of figured it all out and labeled it all up. Okay, if you you can look at this again. So and one of the homeworks, I think I can't actually remember whether it's on this or not, but this homework is, and there's just draw it. The first stage of the histograms is just drawing it, and just doing it. But some people I know have done that. So this is like by far the, it's quite difficult what you've been doing. So if you're kind of thinking, don't really get all this, but maybe what you can get is the first part of it is getting just, if you're just given a table and working out the frequency density. So we're doing like a bit more advanced than that. So but if you can get the first part, then that's really good. Okay, so let me just do, okay, so, okay, I'm just gonna give you 2 things to do. So one of the homeworks this week, which isn't what we've been doing. So just the last sort of 5 minutes or so. Yes, just to confuse you. Yeah, you're right, Poppy, actually. It is on circles. I don't know why, actually. There must have been a reason why. Okay, so because the homework's on circles, I'm just giving you this to do for 5 minutes. This is something that we have done before. Obviously, for the GCSE, what you've got to be able to do is like remember things you've done from a long time ago. And we didn't do, this is the homework this week's on circles randomly. I think because there wasn't anything specifically on data that I could find. So this is just have a play with this for a minute. Just remind yourselves how all these things work. I'm doing so I'm doing a class tomorrow at 11 a.m. if anyone wants to come, and I'll just be picking, whatever, depending who comes. So if someone comes and they couldn't do the homework from last week, then I'm quite happy to go through the homework, or to go through this week's homework, or circle theorems, or whatever it is that people want to do. I don't have much of a plan. I'll have a sort of vague plan. I'm happy to do what people want to do. And we just work through questions and don't really teach in the same way. Maybe lesson then. Oh, I'm doing it at a different time next year. So next year I'm going to do it. Can't remember. It's on our website anyway. So I'm going to do it. It's an afternoon, I think. I think it's actually Wednesday afternoon. I think it's actually a whole day of maths. I think it is. I think it's going to be Wednesday afternoon next year. So I'm going to do Wednesday morning and then one in the afternoon. Yeah. Hi, Jed.
When does the holiday start?
I showed you the thingy earlier. So we've got a lesson. So next week it's the 21st of May, and then there isn't one on the 28th. It's half term, and then we've got after half term, there's 4th of June and the 11th of June. And we're doing a test on that lesson. So start
Thanks.
looking through. You could do, I mean, if you wanted to, this is like a revision sort of thing. So you could do some of that. You can work through some of those. And I probably will actually change the paper. Make a note to remind myself to do that. But yeah, but maybe keep that link up to try and remind yourself before you do this week's homework, if you are going to do the one on circle theorems, then because that link will help you. It's just very clever. It's just very clever to sort of show you all the circle theorems. Have you done them before, Hannah and Clara? Have you done Hannah circle theorems before? We've done them a bit before here, but you might not have done them before. If you haven't done them, you might find it a bit difficult. But maybe we could do circle theorems tomorrow. Maybe that's something that we could do tomorrow. I thought we did do circle theorems. Maybe I'm wrong. Maybe we just did. Maybe actually just did it in the morning or something. Yeah, different class. Okay, maybe we didn't then. Okay, well let's say tomorrow then. I'll do some stuff on circle theorems tomorrow. I think there was a choice of homework. Yeah, so do the easy one. So the easier one is that just area and circumference of circles. But I will do something on circle theorems tomorrow. That's a good plan. Okay, nice to see you guys, and I'll see you tomorrow. Or see some of you, or see you next week. Have a good day.
Thank you.
Bye.